So hi, welcome to the Platform Builders Meetup series. I'm Itay, and I'm going to talk to you about reusable UI components. What are the challenges and problems that you deal with when you build UI for your application? And I'm going to give you the tools and mindset on how to deal with such problems. So as I said, I'm Itay. I work at Wix for 2.5 years. I had the honor of being a co-contributor to the Wix editor and Wix UI library. I'm also a video game addict and code katas enthusiast. And I'm going to start this presentation with a puppy, since it's kind of trendy, and there will be no more of those. I give him a word. So I'm going to start with the story. This is the story of how applications UI usually comes to be, and also what you shouldn't do when you're creating your applications UI. So this is a panel where everything begins, and we'd like to add an input component to our panel. So we go ahead and implement a very simple input and add features to it, add label, and go ahead and implement the input all over our application. And we are now committed to our API, and we should be backward compatible. So we need to add a feature. We'll add this info icon that displays help for the user on hover. And it also should be optional because we need to be backward compatible. And while we're doing this, our text input now aggregates all of our props, and our API is starting to look messy. We also need to support multiple variations of layout. On the right side, you can see an horizontal layout that does not have the info icon. And there are 3 approaches on how to deal with this. There's the good, the bad, and the ugly. Of course, I'm going to save the good for last. And I'm going to start with the bad. The bad is just using class names, multiple class names for multiple variations of layout. And this is very fragile and also really hard to maintain. And moreover, it's not transparent to whoever's using the class name, because you don't know, does your class name support the info icon, doesn't it have it? Really hard to maintain. There's also the ugly solution, and this, I call it UI squeezing. UI squeezing means you customize the CSS from the outside wherever you implement the input. And this is really fragile how to maintain. And I'm not going to tell you which one we used initially because it's kind of embarrassing. Let's add translation. So this is a huge pitfall. And this is what we did initially. We required a translation function from utilities, from application. And we used it in our input component. And this is problematic. Why this is problematic? Our input is now inseparable from our application. It is now familiar with our application concerns. What about BI events? We also initially override the onChange events and send BI events, and further intertwining our input component to our application. It is now inseparable. And so on. We went ahead, and our input is now done. And it's not that bad, right? I mean, it looks good. It's reusable. Well, what's so bad about it? So let's recap. Our input is not generic. It needs to be squeezed in order to fit for all of our use cases. And it also aggregates many props. Our API is messy, and it's really hard to use. And the worst is that it's intertwined with our application. It's inseparable. And now there's another requirement. The manager comes and says, we would like this application to be used, this input to be used in another application. Fantastic. So which leads us to the golden rules. These are the key engineering concepts that we came up with and on which we based our solution. And these are important. And I put it in an acronym so it will be easy to remember. I call this ACC. A for application agnostic, C for consistent, E for easy to use, and another C for customizable. These are the 4 commandments of UI. If you follow these, you're good to go. So UI shall be application agnostic, meaning from the beginning you should separate your UI from application, and you should never ever consider using any application concerns in your UI. You should add features rather than concerns. Your UI should also be consistent, meaning it should look the same everywhere. It shouldn't be squeezed into place every time you use it. And we at Wix have a system. We index all of our inputs, and we have dedicated UX guys that accept or reject new requests for UI components. UI should also be easy to use. It should work right out of the box with zero configuration, without needing to customize it with CSS, and it should be easily assembled like Lego. UI should also be customizable, meaning it should support all of our use cases and be easy to extend. So this is our solution. This is how we took those concepts and implement them. And this is a selected collection of some of our best mechanisms. So I'm going to start with the silver bullet, primitives and composites. This is a primitive. It's just a checkbox. It has no layout whatsoever. This is a variant. It's a primitive with a known collection of props. And this is a composite. This is the layout entity of our UI library, and it puts everything where it belongs. And those also abstract or prototype, which we use internally, and I'll talk about it later. So essentially it looks like this. There's a layout component, or the composite, that wraps all of our sub-components, or the primitives, and the props are distributed between the primitives, where each props go where it belongs. And if we'd like to use another composite or another layout, we just replace the composite with another composite, and it will put everything into place. So primitives, they have all the functionalities. They have no layout whatsoever, essentially the Lego blocks. Composites have no logic whatsoever, and they define the layout and validates that they have accepted the children that we need. Essentially, the template on which we put the Lego blocks. The CSS is going to be defined in the primitives by the composite. And what do I mean by that? Wherever we style our input, we are going to tell it how it's going to look under any sort of composite. So it will be easy to maintain. If I want to modify input, I'm going to go straight to the input CSS and modify it there, and I'm not going to travel among the composites. So how this composites mechanism is implemented. On the upper section, you can see a definition of a composite, and we have a definition for each composite in the system. It includes the composite display name, the class name that it accepts, and what children it accepts, or what should be inside the composite. On the bottom section, you can see how we take this definition and create a composite component that puts the class name, display name, and then validates that it accepted the correct children in the correct order, and that we know how to support them. So there you have a modular UI experience. It's easy to assemble, it's easy to use, and everything from now on just clicks, and it's just a bonus. Prototype by functionality. Can anyone see any similarity between these two components? On the left, we can see thumbnails, and on the right, we see radio buttons. They both support mutually exclusive input and modify those. So we can extract this radio functionality to a prototype component we use internally. And when we expose it, we are going to use either thumbnails or radio buttons, whichever UI experience that we want, use the same mutually exclusive input mechanism. Container everything. So this is a tricky one. The panel header, is it a primitive or is it a composite? It should be a composite, right? but it is supposed to be draggable, meaning it should handle events. So it is a primitive because composites has no functionality whatsoever. So how are we going to make it extensible? So instead of passing text as props, everything inside the panel header should be a content. So it should be extensible inside the panel header. We can add symbols or whatever. We are not limited to the text, and we can easily customize it. Dynamic API. So I like dropdowns. And dropdowns should be easy to use. And this is the easy to use option for our dropdown. You take option, you pass it to the dropdown, and the dropdown just handles it. But this is not customizable, so we support both ways. This is the customizable version of our dropdown usage. We can also, instead of passing options, we can pass children as content, and then let the dropdown handles the options as content, and we can customize inside and replace the option with customized option and use it in which way we like. So when put it all together, dropdown use most of the mechanism in our application. On the bottom right, you can see a context menu, and on the upper right, you can see another customized version of dropdown, and they both use the same popover mechanism underneath. They both open the popover. The popover. They both you can use the options as content. Another tip is using fixed height and flex 100%, meaning your UI should assume it could look right in any possible width, but the height should be always the same. So this will make your layout not to break. Another awesome mechanism is the higher order shell logic that we use in our UI components. Each component is exposed with the compose function that wraps it with any cross-component logic that we'd like to share across all of our components. For example, if we'd like all of our components to be purely render, we wrap everything with the pure render higher order component. And I'd like to drill down to the translation. So this translation higher order component search for React context in our application. If it finds one, it translates all the keys in your components. If there is no context, it just passes the key through. So if you don't want translation when using the UI library, you don't have to even know about it. But if you do want translation, you just add the translation function in the context, and you're good to go. Drivers. What are drivers? Drivers are your contract with your user, or another way for you not to upset your users. This is an entity that is familiar with what your component can do. And when you write your test, you use the driver in order to test your component. You just click, select, and then get and expect. And when you update your component and change your DOM, your driver tests will break. So when they break, you need to fix the driver. And when your users will upgrade the version, they will take the incremented driver version as well. So the test wouldn't break when you update the DOM. So now we can TDD our UI components. We first write the test, then we implement the drivers. Now the driver doesn't work yet, but we use it to write the test for our component. So now we can implement the component, and everything just clicks into place. This is the playground that we use to customize and handle with the component. This is a dropdown. It has a very complex positioning mechanism. It extends when you scroll it, and we also have an awesome live edit for it. And what else? So there you have the tools and mindsets for you to go and build your awesome UI experience. So go there and build, and feel free to ask me anything. Any questions? The question was, are the children mandatory for the composites? And I'll further explain this mechanism. The composites may have multiple variations of children it accepts. For example, there can be an optional child, and then can be children that can be there multiple times. But the composite is a strict definition of what children it accepts. If you would like to use another layout, you would have to define another composite that supports this layout, and it would be stylized differently.